economy program, which is to enhance the reduction of poverty, and other ultimate goal is to decentralize and localize the opportunities. He further advised that the conference should collate country experiences and take them to regional bodies for policy development guide. The Honorable Minister, Dr. Tochukwu of the Federal Ministry of Innovation and Technology, on the other hand, highlighted the production level of cassava in Nigeria, stating that Nigeria is the highest producer of cassava and that the value chain could be harnessed by biotechnology, advanced processing, and digital tools. These tools, when applied, can drive innovation in cassava chain value. He also said that deliberate technology-driven innovation in cassava chain will accelerate industrialization, and his ministry will take the lead in providing the quality and sustainability that is required for this. Some goodwill messages were taken. First, we have that of our Global Alliance of the Republic of Benin representative, who stated that cassava is a symbol of strength, and we are here because we believe in the possibilities and opportunities in cassava chain value. While the Afrexim Bank representative also said that we are reminded of a vital sector as we are gathered here today. Through innovations which promote industrialization, there is a shift from raw commodities to value-added production of ethanol and other values from cassava. Next, on the program, we had the opening of the event, which was done by His Excellency Senator George Akume, the SGF. He highlighted that cassava sustains millions of households today, and it is a key instrument in the agro-industry, and Nigeria is the highest producer of this crop. Yet, our greatest challenge is moving the cassava business to high-value material and generate employment. He further said that the Renew Hope agenda, through policies and that promotes partnership with research institutes for knowledge sharing and policy harmonization. He urged all participants to deliberate on how to expand high yield, strengthening linkage between farmers, and encourage youth and women participation in this industry, while he opened the events. After that, we had a lunch break, and coming back, we had a panel discussion. The panel discussion presented we had papers presented by two different people, and this highlighted the practical issues, field realities, and stakeholders-led solutions to cassava transformation. One of the points that was being highlighted by this is advancing cassava sustainability through skills and technology. The panel stressed the need to adopt and deploy IITA's skills and innovations directly to farmers and processors. They called for a broader dissemination of IITA-developed technologies through trainings and field demonstrations. 2, securing farmland and encouraging farm clustering. 3, women's inclusion and cassava value chains, which the panel emphasized the need for awareness on available incentives for women, outreach programs in interior villages, support system for women involved in cassava production. Women remain central to production and processing, especially in the rural communities. 4, biofortified cassava acceptance. The varieties showed high consumer acceptance and strong promise for nutrition improvement, school feeding programs, food security initiatives. 5, variety performance assessments, which had a coded number 1070539, is recommended due to poor sensory attributes. Due to poor sensory attributes, low cookability, low consumer acceptance. Importance of market-driven variety selection was highlighted to ensure product acceptance and industrial consistency. 6, training, technology adoption and reducing losses. Technologies for improved production, processing, storage, and drying should be fully adopted and supported. These were the suggestions. Emphasis on post-harvest handling, storage improvement, sensitization through extension services, adoption of mechanization to reduce waste. So, I want to say that there was really a lot that was learned yesterday, and I believe that today is going to today's program promises to be more insightful, as we all are welcomed to pay attention, give all our attention to this program so that we will benefit immensely. Thank you all.
Okay, thank you very much, Mrs. Miriam Emmanuel, for the recap. Today, we have Session C and Session D. We have technology and smart system integration and sustainability. We have the role of computer-aided engineering in realizing efficient agricultural equipment for an improved cassava value chain in sub-Saharan Africa, by Adedeji Aremu from Coventry University, UK. We have a poster presentation from technology to business, scaling rural transformation through integrated cassava agro-processing in Nigeria, to be delivered by Emmanuel Okobenin from African Agricultural Technology Foundation. We would have another poster presentation, Critical Interventions for Post-Harvest Loss Reduction in Fresh Cassava in Nigeria. This paper will be delivered by Professor Peter Azikwe Nwalu, the President of the African University of Science and Technology, Abuja. Then in Session D, we will have Global Cassava Market Dynamics. And then we will have Harnessing the Green Gold, Strategic Pathways for Benue State to emerge as a global hub for processed cassava exports, to be delivered by Dorcas Kundam from University of Khan. Then a poster presentation on drivers of cassava commercialization in Southeast Nigeria and implications for food security, poverty alleviation, and inclusive growth by Okoye BC of National Root Crops Research Institute. So if Prof is ready, Adedeji Aremu will take his paper now. The paper is the role of computer-aided engineering in realizing efficient agricultural equipment for an improved cassava value chain in sub-Saharan Africa. Can you link him up? You need to get. Are you ready? Prof. Adedeji Aremu, please unmute from your side if you can hear us. Is he talking?
Can you hear me, please?
Yes, we can hear you. Go ahead.
Okay, sorry about that.
Thank you.
Good morning, everybody. Good morning, professors in the crowd, professors. Thank you for the opportunity for me to speak today. My name is Dr. Adedeji Aremu. I'll share my screen shortly, and so you can see what I have to talk about. So just 1 minute. I hope we can see my screen. Can we see my screen, please?
Yes, we can see your screen.
Okay. Hello again, everybody. I am truly grateful for the opportunity to be speaking at this prestigious conference. My name is Dr. Adedeji Aremu, and I'm a chartered engineer of the Institute of Mechanical Engineering, UK. I'm also a fellow of the Higher Education Academy, UK. And I have been involved on several projects with regards to developing agricultural machinery. And I'm hoping to share some of my experience with you today with the hope of collaborating with everyone here on this platform on projects that advance the cause of our nations. Now, the title of my presentation is The Role of Computer-Aided Engineering in Realizing Efficient Agricultural Equipment for an Improved Cassava Value Chain. So, 1 minute, let's go to the next slide. So I'm going to talk about my previous project so that you have a perspective of where I am coming from, and then we then go to the cassava value chain from my own perspective and how we can fortify local equipment with computer-aided engineering. And I will talk a little bit about what computer-aided engineering actually is and some application of computer-aided engineering in agricultural design. So, I'm a lecturer here in UK, and I teach computer-aided engineering to students from all over the world. Nigerian, British, several African, they all come, and I teach them what this is about. Now, I'm also the principal investigator on a project which is sponsored by the UK government, and the project is worth £209,000. And the project has been trying to improve an agricultural equipment in northeastern Nigeria. So from this project, I've come to discover that we have a lot of capacity in that country and in Africa generally. And if we use it effectively, we can really advance the current state of agriculture there. So I am doing this project in collaboration with the University of Abuja and also a company called Mustard Seed High International. It's an Adamawa-based company, and they are into the manufacture of agricultural equipment. And the whole idea is if we can get them on board, be able to do some of these manufacturing agricultural equipment for cassava, that would be great. So our project about creating an equipment called the seed planter. The seed planter is a device in which you pour in seeds and you simply roll on the ground, and the seed goes straight into the ground and plant there. This has remarkable benefits for low resource areas, small farmers who cannot afford big factors to do this kind of a thing. And we've been able to amplify the sale of this seed planter by using computer engineering by ×6. So before we started the project, the sales were just a fifth of what it is now. And our area of focus is particularly on this area in Nigeria, Damaturu, Potiskum, Kika, Kuma, and several areas. And a lot of them have been buying this planter. And again, some of the knowledge we've gained in doing this can be put directly into realizing cassava equipment. Now, I'll also say that I was also involved in a project where we trained several people in computer-aided engineering in Nigeria, and that project was sponsored by the Royal Academy of Engineering. We reached about 2,000 girls in the northern part of Nigeria, went to the high school, and we told them about the importance of computer-aided engineering for the female engineer, and that was really, really very productive. 5 of our students on this project won 3 of our students on that project won 5 global awards when they competed with people in Asia, Africa, Europe, and Middle East. And that is what I worked on. So let's carry on. So when it comes to cassava, we can see from this map, when I got this map, World Population Review, that Nigeria remains the highest producer of cassava on the world. And you can see indeed several parts in Africa are also producing large volumes of cassava. That means that this crop actually offers us an opportunity to gain an economic advantage. As such, the more we look at how we can improve the value chain for cassava, the better it can be for us economically. Now, cassava is a very useful crop. It's used as food, as we all know, and we all know it's used as livestock feed. So this slide is blank for a reason. I know we all know what cassava is, so I'm not going to press it too further. However, what is less known in the value chain is that cassava is also useful for making paper and cardboard. It's also a means of biofuel. And just imagine, we are converting all our cassava, a lot of it, into biofuels in which we are selling all over the world. The state of our economies in Africa will indeed be much better. And also, it is a very valuable component in pharmaceuticals, where it is used as a bind to bind the drug together, and also in the drug delivery system. So it's a very, very, very valuable crop. But the problem we have, the challenge we have, is that cassava spoils quickly and is susceptible to diseases. There's also the high cost of infrastructure, and climate variability is also an issue. And storing and transportation, our UK project, we went into the project was because they were importing some agricultural devices and seed planters from abroad, and they were using it on our land in the northern Nigeria. But those devices were failing because it wasn't adapted to us. So what that tells me is that both the cassava value to design our own equipment, and we've done that. We've got a better performing product, and we can do the same also for cassava. Now, the cassava value chain is very vast, and I'm sure all of us here who are experts in this know about this. But what I wanted to say is that for each of these value chains, there is an opportunity to exploit computer-aided engineering to improve the quality of equipment which is being made to achieve that particular level. All abroad, in different parts of the world, computer-aided engineering is used by developed nations to design all kinds of things. They use it to make cars, they use it to make in the military, they use it to make all equipment. Indeed, some of the tractors and agricultural equipment we are importing have been projected to some computer-aided engineering before it is manufactured, and that with the type of equipment, computer-aided engineering can affect all the levels of the cassava value chain, everything, both in designing the transport of that, the equipment used to plant the cassava, the equipment used to process it, and all that. Now, this is an example of processing of cassava. I said gari. Process of, it's gari, obviously. Process of cassava into gari, and these are the different ways to use computer-aided engineering. We can come up with a device which is much more energy efficient, which is made with our local materials, and it's more affordable for importing a lot of this equipment, and it's not sustainable. It will not really allow the value chain to have much value. So using computer-aided engineering with equipment to be more energy efficient for the use of the masses. Now, what is computer-aided engineering? I'm sure some of us know this already, but please permit me, it's simply using the computer to do that. So every equipment, every component you see on that, on any agricultural machine can be designed properly with computer. In Nigeria might not be able to compete at the moment with the car. You do some simulations where they can design a lighter car, and if you don't know, the more light your car is, the more energy efficient it is going to be. So we can do that so that the amount of energy needed to run an agricultural equipment for processing cassava becomes affordable for the common man. And when that happens, the cost of the product you get from that device goes down, and it becomes much more competitive and more available to the small and medium scale farmer. Now, in high school, a lot of us that did engineering or sciences know the spring. If you know the spring, with a course, you can calculate the extension. The point, and the problem is that all these formulas we learn in high school and university, they don't translate to